Audio Jungle. Audio Jungle.
All right, so guys, last session we had seen that slope of streamline for the constant stream function. So what was the slope of streamline? Slope of stream line or constant stream function, or it is well known. Basically, along the streamline, stream function will be constant. So if you are saying slope of streamline only, okay, that is also correct. Slope of streamline, what we got that time last lecture, if you see, dy by dx is the slope for psi is equal to constant, and we got it was v divided by u, yes or no? So this is the one result we achieved last session. Now if we'll go for the next, what we got that and conclusion that last session, if you check, for the stream function we had seen the streamline and characteristics of a streamline also we had seen. Like suppose you are drawing a streamline here, this is what is streamline, okay, this is the one streamline here, and streamline will have a direction also because it will show the direction of the flow. So along this streamline, stream function will be constant. So I'm considering this is the streamline 1, okay, and this is the streamline 2. So for this stream function, just say it is psi1 and constant is nothing but c1. Similarly, the second streamline, and along this streamline, stream function will be constant. Just say it is psi2 and constant is nothing but c2. Yes or no? That's the mean of it. So basically, stream function is a constant along streamline. Okay, stream function is a constant along streamline, that you know. So this was the conclusion. Last lecture we had seen stream function is constant along a streamline. If I am drawing, this is the one streamline, okay, so here psi1 will be c1 just like previous diagram, and this is the another streamline, here we have psi2 is equal to c2. All right, so now based on this I am considering two streamline 1 and 2. Magnitude wise, just say if this stream function is psi, so this stream function is what, psi plus d psi. I mean there will be a different value for two different streamline. I am just writing the stream function. For first time I have written it is psi, for second I have written psi plus d psi, means there is the increment, you can say. All right, this is the mean of it. Now what I want to show you, I just want to show you that difference. If between, because this is the two streamline and perpendicular to this streamline, that flow will not be possible. I told you, I explained in last lecture, like perpendicular component, velocity component perpendicular to the streamline will be 0 always. It means there is no perpendicular flow. So where will be the flow? Flow will be along the streamline. So it is like a path, okay. This streamline will be considered as a path. You can say it is a solid path also, okay, and solid path in the sense there is no perpendicular flow, or you can say there is no leakage, okay. That perpendicular flow will not be possible, means this flow will not be possible, okay. Here flow will be what, 0, this velocity will be 0, so it means there is no flow. But where you will get velocity, you will get velocity here, so this velocity will not be 0, here will have a velocity. But perpendicular component, everywhere perpendicular, you may get 0 velocity. That's the characteristics of the streamline. Yes or no? Here velocity will be 0. All right, that I had explained. So it is just like a channel, okay. Now you have channel. So along the flow there will be along the streamline there will be flow. Okay, so now we are having two streamlines, psi1 and psi2. So definitely it will be like a one channel. Okay, we can say this is one channel. Okay, so along between two streamline there will be flow. I just want to calculate the what is the mean of the difference of two streamlines. If I am writing psi1 minus psi2 mod, or it is also psi2 minus psi1, it's your choice what you want to write, you can write. What is the meaning of it? Okay, so the meaning is very clear. This is nothing but the flow rate or discharge per unit thickness. If I'm considering depth of the flow is what unit, so this difference psi2 minus psi1 will give the flux or flow rate or discharge per unit thickness. So actually this psi2 minus psi1 is nothing but v into ds. Okay, v into ds. Ds is the one dimension. Ds into thickness if you multiply. Okay, if you multiply ds into one thickness you have considered unit. Now this will be what? Area. Okay, here you have taken one in the sense unit thickness. One means unit thickness. So this is what v into ds. So this is basically what is the velocity into area? Velocity into area is nothing but discharge, but here I have taken unit thickness, so it will be like a discharge per unit thickness. Hope you understood this. So this is what? Discharge per unit thickness. All right, or this I can write q divided by t. What is the q? Q is the discharge. Okay, it is the discharge or or flux or flow rate. T is the thickness or depth of flow. So what is the mean of psi2 minus psi1? Now it is very clear. What is the mean of psi2 minus psi1? If you are writing psi2 minus psi1, or you are writing psi1 minus psi2, meaning will be same. So that meaning is what? Q by P. Okay, which means it is nothing but discharge per unit thickness of flow. Discharge per unit thickness of flow, or what you can write psi2 minus psi1, or it is also psi1 minus psi2. It is nothing but q by p. It can be written as flux per unit thickness of flow, or also you can write what you can write flow rate per unit thickness or per unit depth of flow. All right, this is the mean of it. What is the unit now? Unit of stream function. It is discharge q by t. What is the discharge unit? It is volume flow rate meter cube per second divided by thickness is what? Meter. No? It is nothing but meter square per second. That you need to remember. This is the unit of psi. Okay. This is very important. No? So whatever I have written here, you can say this one or this one. all points whatever I have mentioned here, it is important. All right, now, so next, this part is hope you understood. Okay, so stream function can also be defined here. I can write, so what is the conclusion of this formulation? What is the conclusion of this formulation? What formulation I have given to you? That meaning is stream function. Stream function can also be defined as the flux or flow rate per unit depth between two stream. This is very important. Okay, this is very very important. Done. Now the next is like continuity equation for the 2D flow for an incompressible and steady flow, so I just want to satisfy that stream function to the continuity equation, and then we'll see what is the result of it, and then we'll see what is the conclusion of it. Okay, so we can write here, what we can write, continuity equation in 2D flow for steady and incompressible. Okay, what is that? What is the continuity equation? You all know, it is nothing but dou u by dou x dou v by dou I. We know stream function defined as follows. What was that stream function? It was defined if you are taking derivative of stream function in which direction? In x direction, then you will get velocity in y direction, which is v. Similarly, if you are taking derivative of stream function in y direction, then you will get velocity in x direction, but it will be negative sign. That I already have explained. So now you can say this is equation 2 and this is what? Equation 1. We need to satisfy u and v value we keep here in the continuity equation, and we'll see the result. Some interesting thing you may get. Okay, here we need to satisfy this. So what we'll get? We'll get here dou by dou x. What is u? U is nothing but minus dou psi by dou y. Similarly, dou by dou y. What is the v? Check. V is nothing but dou psi by dou x equal to 0. So what we'll get here? Dou square psi divided by dou x dou y plus dou square psi by dou y dou x is equal to 0, or what we'll get? Dou square psi divided by dou x dou y and dou square psi by dou y by dou. What is this? Okay, this is the real. What is this? Let me put in box. Okay, what is the mean of it? Simple meaning is very clear. This now stream function is what satisfying to the continuity equation. Okay, so what is the conclusion part here? What is the conclusion part? Just check. So existence of stream function means a possible case of fluid flow. Existence of psi means a possible case of fluid flow. If stream function is what satisfying to the continuity equation, continuity means what? By the word only you can understand. Continuity means there is the continuous flow. Means it is showing the continuity of the flow. So psi is existing or it is satisfying to the continuity equation means it is showing that there is the possible case of the fluid flow, but it doesn't matter it is rotational or irrotational. It is not, so it is not stating the flow is rotational or irrotational, but it is stating that there is the possible case of the fluid flow. Okay, fluid flow, the flow here need to add the flow may be rotational or irrotational, right? So what you understand, that if the existence of stream function, so it will show or it will state that there is the possible case of fluid flow. If it is satisfying to the continuity equation, then it will tell like okay, there is the possible case of fluid flow. It may never say it is rotational or irrotational. So for the rotationality or irrotationality we need to check another thing also. Okay, we need to check the another thing also, that we'll discuss. Okay, that will discuss once I will finish the angular velocity, that formulation and all, then I will discuss you what is the condition of the rotational flow and irrotational flow. Okay, based on that parameters will come. Hope up to here it is clear to all. Now we'll go for the next function, which is called potential function. What it is called? Potential function. Potential function, it is denoted by phi. Okay, it is also only scalar function. So how it is defined? So basically it is defined as a scalar function of space and time, all right, such that such that its derivative its derivative in any direction gives the velocity component in that direction. Okay, meaning is very clear. I'll show the diagram so it will be more clear to you. I'm just going to draw the 3D. This is what x, y, and z. Now onward, you all know in x direction what is the velocity component? It is u. In y direction velocity component v. In z direction velocity component is w. Yes or no? So how it is defined? Stream function. It is first of all phi, the function of space x, y, z and time. Why I am saying time? Sometimes steady, unsteady terms will come. If unsteady term will come, then only t function will be there. Otherwise, if it is steady, it means with respect to it is constant. And believe me, till our BTech course or GATE syllabus, we have only steady aerodynamics. We do not have unsteady aerodynamics. Okay, so time function will not come. But here I am saying it is the function of space and time, just for your knowledge. Okay. So we are considering steady flow, hence t will be constant. So we are not taking any derivative with respect to t. Anyway, it states that the derivation, or you are taking derivative of stream potential function in any direction, just say in x direction, then it will give velocity in component in that direction. In that direction means if you are taking derivative in x direction, it will give velocity component in x direction only. What is the velocity component in x direction? It is u. Similarly, if you are taking derivative in y direction, it will give v, and similarly if you are taking derivative in z direction, so it will be w. So this is what? This is the all about potential functions. If you are talking about x direction, this is the x direction, this is what? Y direction, and this is what? Remember, this is for 3D flow. I mean, it is maximum, it is valid to 3D, but stream function was valid only for 2D flow. Yes or no? This is the velocity potential function in Cartesian coordinate. This is what? Cartesian coordinate. Cartesian coordinate means x, y, z. Huh? This is the Cartesian coordinate. The same thing you can write velocity potential function. You can give heading velocity potential function in polar coordinate. Okay, I am considering 2D, so polar r and theta. If you are considering 3D, so r, theta, z. But for our simplicity, just for information, I am just writing for 2D. So r and theta term will come. So if you are taking velocity component in tangential v theta, which is called tangential component, so it will be 1 upon r dou phi by dou theta. If we are writing radial velocity component, then this will be, I need to write tangential component, and this is what? Radial component. So this formulation is very important. Okay, you all need to remember this formula. This is very special. All right, always remember, this is very important. Now, just like we had done for the string function, so but here in the velocity potential function is what? For 3D, but for our simplicity, to minimize the calculation part, we can take 2D. So calculation will be very easy. So now I am going to write the next, it is called characteristics of the potential function. Okay, what I can say? I can say phi is the function of x and y. What is the mean of it? Okay, this is the characteristics I am just explaining. Characteristics of velocity potential function phi. Yes or no? So phi is function of x and y. What is the total derivative of the potential function? It will be what? Dou phi by dou x dx, dou phi by dou y dy. D phi is what? What is dou phi by dou x? It is u dx. What is dou phi by dou y? Just now I have explained here. Dou phi by dou x is nothing but u. Dou phi by dou y is nothing but v. So I can write this, yes or no? Now, what is the mean of the equipotential line? That concept will come here. So I need to mention one note. This is the note part. Okay. So, what is the equipotential line? Equipotential, sorry. Equipotential line. How it is defined? It is defined a line of constant potential function. Line of constant potential function or line of constant velocity potential function. Let me complete this full word. Let me complete this. A line of constant velocity potential function called equipotential line. Okay. So for equipotential line, for equipotential line, what will be phi? Phi will be constant. Yes or no? For equipotential line, phi will be constant because equipotential line itself defined as a line of constant velocity potential function called equipotential line. What is the velocity potential function? Phi. So for equipotential line, line, what will be phi? Phi will be constant. Then what will be d phi? It will be 0. Yes or no? What result you got here? You got d phi. You got d phi is equal to u dx v dy, and for equipotential line d phi is what? 0. Yes or no? It means u dx v dy is 0. What is dy by dx? It is dy by dx. It is nothing but minus u by v. And here you have taken phi constant. Yes or no? Okay. dy by dx, phi is equal to constant is equal to minus u by v. Now this is what dy by dx is what? It is the slope of dy by dx is what? It is the slope of equipotential line. Now we have two slope. What we have seen? Slope of streamline and slope of equipotential line. What formula we have seen? It was slope dy by dx because it is a streamline, so size constant. And what was that? Last class I had derived, but here in starting also I had written it is dy by dx is what? V by u. Yes or no? It is V by u. It is V by, and this is the slope 1, so I can write m1. Similarly, slope for the equipotential line, just now we had seen what was that? Pi constant, and just now we had seen it was minus u by v. This is slope m2. Yes or no? Now, ninth standard mathematics geometry, if you remember algebra, what we got, if there is the two lines are perpendicular to each other, two lines are perpendicular to each other, like this is the one, okay, and this is the another one. So here for this line slope was m2, and here for first line slope was m1. If they are perpendicular to each other, where they are crossing to each other, if it is perpendicular 90 degree, so we got that slope of both lines m1 and m2 will give minus 1. This is the very basic mathematics, ninth standard. Do you remember it? Called orthogonal. Orthogonal to, or called orthogonality of two lines, or orthogonal to each other means they are perpendicular to each other. Yes or no? This was the mathematics in ninth standard. Okay, we had seen. Now, so we are having slope of streamline and slope of equipotential line. Both, if you check m1, what we have m1, which is equation of slope of streamline v by u, and what is the m2? Check slope of equipotential line minus u by v, minus u by v. If you check m1 dot m2, what will put? Okay, it is cancel out now. So meaning what? Conclusion what we got? Conclusion is very clear. Just now here I had shown you, this is the mathematics, ninth standard mathematics. So what is the conclusion? Conclusion is streamline and equipotential line are orthogonal to each other. Streamline and equipotential line are orthogonal to each other, or both are perpendicular to each other, or both are normal to each other. All right. So if I say this is the streamline, this is what is streamline psi 1, psi 2, psi 3, psi 4. Okay. So these are the equipotential lines. And everywhere they are perpendicular to each other. Yes or no? Everywhere, anywhere you can check. All right. One is very special thing. What? Streamline will have a direction, but potential line, equipotential line will not have any direction. Okay. So when that's the reason, if you check equipotential line, that arrowhead I do not have drawn arrowhead, but for the streamline I have drawn arrowhead also. So arrowhead is showing like direction of the flow. So streamline, you can say that streamlines are having eyes, but equipotential lines are blind. They cannot have their own direction. So how to decide the direction of the equipotential line? Very simple. Whenever they will ask the direction of the equipotential line, first you have to draw streamline direction. Okay. And what will be the streamline direction? The direction of the flow. So direction of the flow will be the direction of a streamline. Okay. And perpendicular to that streamline will be called as a equipotential line. Okay. So I hope you understood this. Okay, this is very special sometimes. Okay, fine. Now the same thing will do for just like for the stream function we had drawn. Okay, so similarly will I mean for the stream function we had satisfied stream function with the continuity equation. So same thing will do for the potential function also. Will satisfy this potential function to the continuity equation. Okay, so now check. We'll write the statement. What will be the statement? Continuity equation. Okay, for incompressible and steady fluid flow. Yes or no? And I'm writing for 2D. Even though you can do for 3D also, no problem. It's your choice. Because potential function is valid for 3D, so you write it what you want. Doesn't matter. So what is the continuity equation? It is dou u by dou x plus dou v by dou y. Okay, if you want 3D, you can write 3D also. Fine, is equal to 0. Now check. We know velocity potential function u is equal to dou phi by dou x. Okay, what we'll do, we'll satisfy this value with the continuity equation. Yes or no? Now we need to write what we'll do. U, what is u? What is v? What is that? This you can write. Yes or no? Grade square phi. What is this? What is this grade square phi? This is nothing but called as Laplace equation of velocity potential function. What is the mean of it? What is the conclusion? What is the conclusion? Conclusion is if velocity potential function if velocity potential function phi, that is phi, that is phi Laplace equation, it is a case of it is a case of possible fluid flow. Okay, which means which means which means continuity of flow, continuity of flow. Yes or no? Always remember. So this is the conclusion point for the potential functions. So today, like what I had explained, it was all related to the stream function and potential function. Okay, that property of the streamline and that characteristics of the potential function, similarly characteristics of the velocity potential function as well as stream function, all I have explained, that like how to draw the plot or graph if it is required, or direction of the velocity potential function if it is required somewhere. So how to draw it, right? Without drawing a streamline, you cannot draw the velocity potential line, or equipotential line, sorry, equipotential line. So all those things what you have seen today, it was very important. Okay, and next class will talk about the angular velocity. Then I will show the how we can relate that potential velocity potential function and stream function to the angular velocity, how to relate it. Okay, so that we'll see in next class. Thank you all, thank you so much.